Now, don't get me wrong. I'm not saying we don't need mechanics, but I need a vehicle just really primarily to get me from point A to point B. And as an embedded engineer, oftentimes you're saying, I don't want to be a data scientist. I can't be a data scientist, but I need a way to get from point A to point B so that the devices that I'm working with, they can now bring additional value to my customers. And so for me, the use cases that I really enjoy is not so much a technical one as so much as when I have an opportunity to sit down with a partner, sit down with an end customer at times and show them and illustrate how they can get from point A to point B and to see that light bulb and to see that value transition from technology to gratification. Those are the use cases that I truly enjoy.
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today, we're talking with Blair Newman. Blair is an accomplished executive with more than 25 years of experience creating business value within the information technology industry. He's a decisive leader, managing and overseeing P&Ls, building pipelines, and generating multi-million-dollar cost savings via acquisitions and IT transformations. He is currently the Chief Technology Officer at Newman AI, where him and the team help companies automatically build extremely tiny and explainable models without needing a machine learning background. Prior to his current role, he was head of computing services and solutions at T-Systems North America for more than 10 years. Thanks, Blair, for being on the program today.
Thanks, Justin, for having me. I appreciate it.
Well, awesome. I gave a little bit of a background for you here in the intro. How long have you been the CTO where you're currently at, and how did you end up landing in that position, I guess?
Okay. Yeah. So I've been with the organization for now, it will be 7 years and probably a little over a month. So I've had the opportunity to see the organization grow, and to some degree, we kind of went through our own transformation throughout this period. It's been a fun ride.
Awesome. Well, so how big is Newton?
I would say it's our brand. It is the brand of our TinyML platform. The organization that I work for, Bell Integrator, we've been around for a little over 17 years. And as I've mentioned myself, I've been with the organization for going on 7 years. So we've historically been a systems integrator. And as I mentioned, one of the things that we were looking to accomplish since I had the opportunity of joining the organization is my approach and my philosophy has always been, how do I bring let's say technology, or how do I bring services to the fingertips of your customer? Whether it's our direct customer or if we're working with a partner, let's say their end customer. And that's been one of our core objectives since I've joined the organization. And I think as we have an opportunity to talk a little bit more about what we're doing with Newton, hopefully I'll have an opportunity to illustrate this a little bit more.
We'll spend a lot of time talking about as much as you would like to talk about Newton. One of the things I do like to talk to people about, since you're sort of a thought leader, I think in this space of artificial intelligence and machine learning, TinyML. In fact, I saw you present at the TinyML Summit. That was awesome. I really, really enjoyed your presentation. How do you define AI and machine learning? If somebody that is outside of the field, how do you tell people what you do or what your product does at more of a layman's term level?
I like to explain it hopefully as simply as possible. I've actually had the opportunity to establish a AI club at my youngest son's high school. Some of the participants or some of his peers, they were new to, let's say, any level of technology. Some have began to get a little bit of an exposure to artificial intelligence. But one of the analogies that I used that I believe that was able to resonate with them, and hopefully also for those listening, is that when you begin to think about machine learning to a large degree, you can really contrast this to, as an individual, your path to learn. And starting off with, normally, how do we educate ourselves, right? We normally educate ourselves with some historical information where oftentimes this information is presented to us maybe in the form of a book. Maybe nowadays we're reading some various white papers. So you need to go through that process of education, right? Or learning to a large degree, right? And then once you kind of go through that process of understanding, let's say, some of that background, then at that point, you'll be able to hopefully make some decisions based upon some of the historical information that you may have picked up along the way. And when you begin to think about machine learning, what we're trying to accomplish is we're trying to replicate some of that decision making that we make or we've made as we've gotten older, more experienced, et cetera. So you typically want to start off with some historical information, hopefully factual information. It's still the old tenet of junk in, junk out, still rules the day. So you want to make sure that you have some information that you can then leverage and use as it relates to training the model or creating the model. And just like when you're in school, you read chapters 1 through 5, and then you have an instructor and they say, hey, I'm going to test how well you've retained that knowledge and if whether or not you can answer questions correctly. And we do something very similar when it comes to machine learning or artificial intelligence. We want to validate, we want to test the model to ensure that it is making predictions with as high or a high level of accuracy as we possibly can get. And as we grow, we continue to learn, and sometimes this turns into an iterative cycle. And the same thing with machine learning. Over time, maybe your model may begin to decay, and you may need to go through, you may need to give it some additional information so that it can either you maybe build a new model and start from scratch, or you may do something what we call reinforcement learning, where you're training the model on the fly, and then you're hopeful that the predictions that you're making will continue to be as accurate and valuable as possible.
I love that analogy. And I was just thinking about kind of going back to school for a quote unquote tune-up, I guess, right? If there's other classes and coursework you need to take, then yeah, that's just kind of getting your model improvements over time, making it smarter and smarter. This is really cool that they're kind of embracing this technology and sort of like interested in playing around with it. Do they see the tie between machine learning and artificial intelligence and say like Google or Siri or Alexa or any of that type of stuff?
They definitely know that it's out there. They definitely know that they interact with it daily. I think probably one of the most eye-opening experiences for them, and it's an ongoing experience for myself as well, is how actually invasive machine learning is in our lives today. So one of the things that I had an opportunity to illustrate was I just played a video and I just asked them to count how many times in that video did this particular individual interface with some form of either artificial intelligence or machine learning, et cetera. So that was quite an eye-opening exercise for them to begin to think expansively as to really how often you are interacting with some level of technology that oftentimes, at least for themselves, they didn't know was influencing, their actions, their behaviors, their thought processes, et cetera. So that was definitely an eye-opening experience for them.
Yeah, for sure. What's a day in the life of a person in your role at your organization?
Well, one of the tenets that I mentioned when I started with the organization is, how do I bring these services to the fingertips of our customers? And when we began the journey of building out this platform, which was roughly around, let's just say, going on about 4 years ago, we started out really with one mission. How do we enable machine learning for everyone? And we meant that in a very literal sense. How do we make machine learning available for everyone? And now as TinyML has kind of matured and really began to grow exponentially, I would say, when you think about edge devices, when you think about bringing intelligence to the edge, it's really kind of really pulling forward that vision that we had at the time. Now, for myself, when I think about a day in the life, one of the things that I truly enjoy is, let's say, having the opportunity to turn the light bulb on for anyone. A lot of times I find myself both internally as well as externally communicating with potential customers and partners to really help them understand, and oftentimes just articulating how, let's say, embedding a model can really bring intelligence to the edge. Because, to some degree, we've almost come full circle. Maybe 10 years ago, there was this huge movement to bring everything to the cloud. it was to some degree, it was a race, how much can you put into a cloud, whether it was public or private, but it was this huge, huge race to put as much as possible in the cloud. We've almost come full circle and we're saying, how much now can we bring to the edge? How much intelligence can we bring to the edge? When you challenge the organization, now I'm going to shift a little bit internally. When you challenge the organization and you say, I want to make machine learning or I want to make tiny ML available to everyone, the first response sometimes is, well, that's not possible. But, those are some of the headwinds that we had to address back then. And to some degree, those are the headwinds that we have to address now. Whether it is just simply just building a model automatically from a zero code perspective, whether it's producing code and I say, hey, I want us to be able to produce a model that is device agnostic. I want us to be able to produce a model that will allow someone who has no educational experience as it relates to being a data scientist to be able to successfully implement a model and embed that model into their MCU in 2 days. So my objective is to keep pushing what sometimes may seem as the impossible. And that includes interfacing with customers. That includes interfacing with internally. And I'll give you another example. And I'm sure that at the TinyML event, you probably heard me speak to this. I would probably say even still today, 99% of all models that are built, they start out with a fully connected network. They're extremely large. And then there are a number of different tried and true technologies that everybody is applying, quantization, pruning, et cetera, to reduce the size of those models so that they can be embedded into memory constrained devices. And no matter where you go, you even go now to Google or STM Micro, and they're building on the same approach, the same methodology. And what we said, which hopefully now can bring to home a little bit, when I say my objective was to make them impossible reality, where we build all of our models neuron by neuron from the bottom up. And we're one of the only organizations that take this approach, which allows for us to now get to the point where we've began to set the standard that all of our predictive models, all of our machine learning models that we produce are less than a kilobyte in size.
Yeah, that's crazy.
And if there's anything larger than that, then we have to have a discussion. So we've really kind of taken the bull by the horns in an attempt to kind of redefine how machine learning is approached. I vacillate back and forth between helping customers to understand how this is even possible and how they can get value out of it, as well as continue to impress upon individuals in our organization to keep pushing that envelope.
Sounds like a fun role for sure. As you were talking about your product, which I want to have, maybe you explain a little bit more, maybe some specifics or some customers you work with or, whatever. Have you heard of Teachable Machine? It's a project, I think it was put together by Google, but it's an in-browser solution. And basically you can turn on your camera and you can have yourself smile 50 times and then frown 50 times or whatever it is. And then, so you're essentially training the model. And the only thing that I think is really cool about it is, number one is you can generate a TensorFlow model. You can download and do it wherever you want, but also just the getting to your point of, putting the power in anyone's hands, the accessibility, basically a 10-year-old could train a model through this tool. And I love that concept because I'm a technologist at heart. I actually teach at a local university here as well. So I feel like I'm definitely an educator. And the more I guess knowledge you put in, the more hands, throughout the world and even younger age groups, sort of like the better. So I really commend you guys on what you are trying to do. The fact that you can do stuff in 1K too is phenomenal. I'm assuming there's a lot of like intellectual property built in. Have you guys been filing patents and stuff like that in that area?
Yeah, absolutely. We, as I mentioned, we began to build out our platform a little over 4 years ago. And you might say that initially, just for the sake of today's discussion, we were just doing AutoML. So we worked in a number of different verticals, let's say in the retail space, in the financial services space. And our platform allows for customers to do more than just TinyML. They can do predictions via the web. You can publish your models via an API, et cetera. it's actually kind of funny. We actually kind of stumbled across producing tiny models. It wasn't our objective. Our objective was that we worked on a project. It was with a local auto retailer, and they wanted to produce a application, a mobile application that allowed for their customers to take a picture of their vehicle, and then it would identify that vehicle and then map the accessories that were associated with that vehicle. Because
Okay.
I'm sure if you go into AutoZone or Pep Boys and you want to get an accessory, you got to pull out the big manual and you have to find your particular model of the car. You have to find the part number, and it's very laborious to take that approach. And they said, we don't want to do that. Just we want to give them the mobile phone, take a picture, identify the accessories, and then we're also looking to extend their reach outside of their brick and mortar location. And they said, hey, just go back 10 years. I've been identifying vehicles. We probably at the time to build the models, well over 5 million images to make it work. But the models were huge. They were very large. We did finally get it to work, but it was a clunker. It was a clunker. We got it to work, but it was a clunker. So one of our objectives was, hey, how can we build models but not requiring, such a significant amount of data? And in the end, it wasn't scalable. And that's where we kind of challenged each other internally to say, okay, let's do something different. And that's when we flipped the paradigm on its head, just eliminated starting out with a fully connected network. We don't use TensorFlow. It's an algorithm and framework that we've developed completely in-house, and it is patented. And as a result, even though we were just serving, let's just say, some of the major verticals, one of the things we began to realize were, wow, these models are really small. As TinyML picked up, we said, oh, wow, we can really—
We're onto something here.
We think we can play in this area. And so it wasn't actually our intention to really be active in this space, but this is more recently where we kind of almost function exclusively in the TinyML space since we've had an opportunity to be so successful in this area.
That's awesome. You've been sort of talking through it, I guess, what you guys do, but I mean, you guys offer this platform, right? And you mentioned API, so maybe you can talk me through, I guess, how you guys work. I mean, I need to have an MCU. Do I need to run some sort of operating system on my local system? And how do I bring your software into what I'm building?
I'll take you through our key 3 tenets as it relates to being able to really make AI available to everyone. So starting number 1 with ease of use. And of course, there's a number of platforms that, are AutoML based, et cetera. But one of the things that we really focused on is having an automated pipeline, really a 3-step pipeline that all of our customers go through. As I've mentioned, is zero code, 100% zero code as it relates to being able to produce one of the machine learning models. So our customers, they drag and drop their data onto our platform. We kind of focus in a couple of key areas: regression, classification, whether it's binary or multi-classification. We also work with time series, audio, say digital signal processing. Also included in our platform is NLP. Now, one of the areas where we have not integrated into our platform at this time from an AutoML perspective is video and imaging. But all of the other task types or use cases, they're available, where a customer, you just drag and drop your data. You identify your target variable. So depending upon which sensor you're using, which MCU, or what your use case is. And depending upon your task type and your device, then you would select if you're using a 32-bit device, if you're using floats, et cetera. One of the next areas that we really, I would say, we kind of kick the door down is that our models, in addition to being device agnostic, also natively come out and they support 8-bit and 16-bit microcontrollers. So this also created another opportunity for our partners, our customers, to really extend the reach of intelligence. So you would then select if whether or not you have an 8-bit controller, 16-bit controller, 32-bit controller, et cetera. Then after that, you just click Start Training, and then we automate everything else from there. Now, once the training is complete, you go into the 3rd step of the pipeline. Now, if you want at this time, you can run predictions via the web. So you say just for some reason you haven't gotten to the point of embedding, you have a holdout data set that you want to test and validate the accuracy. So that's available to our customers. We also then at that time, we will publish a REST API, which if you wanted to run predictions remotely and query the API, you can do that. And then lastly, of course, from a TinyML perspective, then our customers can select and hit download. And then at that point, they can download the model, which comes in C code. So at that point, when it's downloaded, then they can then move to the next step of embedding that model into their device of choice. So even though it is our own proprietary algorithm, all of the models that we produce, they're open, so they can be converted into Onyx, H5 format, et cetera. So there's no limitations in regards to being able to take advantage of the models that we're producing. So that's what I would say is purely, let's say, from an ease of use perspective, as well as from whether you want to say is portability or the ability to access really any device that you may be working with for your particular use case. And then lastly, when we began to talk about making AI or machine learning available to everyone, our platform is available 100% free for anyone. So you get full use of our platform where you can build your models, you can test your models, and you can download the models with no tiebacks to our platform whatsoever. And that's available to anyone, irrespective of the use case that you may be working with. And we work very actively with a number of different, whether they're just doing it from educational purposes or whatever the case may be. So those are kind of the three areas that we really kind of touch on is from an expense perspective is 100% free. And then of course, we've kind of knocked down all of the headwinds as it relates to usability.
That's fabulous. Yeah, I mean, on your website, you can basically start for free. Is there a cap, I guess, on so many models to train, or when do things have to flip over and start costing you money?
No, absolutely not. So
Okay.
it's unlimited training, unlimited predictions. Our business model is that we typically are working with various partners. So various silicon providers, they are looking to extend their value proposition and their service chain to enable their customers to come directly to them and then not only be able to purchase the silicon or the sensor, but then be able to go through the entire service chain from purchasing the silicon to then having an embedded model. So we will work with our partners to help define and establish use cases that their customers can consume. So obviously it drives a lot of value for a number of our partners because now their customers can come to them not only to just purchase the silicon, but also to go through the entire use case and implementation. So we'll be shoulder to shoulder, sometimes underneath the umbrella of some of our partners, enabling their community to go through and implement and embed models into their respective devices. And so we will have a commercial engagement with a number of those partners on a use case by use case basis where they identify where their community can get the most value out of.
Awesome. Yeah, I just looking, there's tons of use cases you have here, edge devices for home monitoring, there's home security and automation, pet tracking. Yeah, various case studies. Do you have a favorite one, I guess, of you guys have done recently?
We do make available a number of what we call pre-trained use cases. So the data set is there. We provide all of the necessary information in order to, let's say, produce the model. I would say a couple of the use cases that I really enjoy is really anomaly detection and to some degree, let's say, fault prediction. I enjoy these because, especially anomaly detection, because oftentimes those can be some of the more challenging use cases to implement. But one of the things that I did highlight to you is that my passion is behind bringing a light bulb on. And so have an opportunity to work, let's say, with the embedded community or just different members of that side of the house, because in reality, there's a finite amount of data scientists. On the other end, especially when you're working in the silicon space, there's numerous embedded engineers that oftentimes don't know where to begin, have some questions and doubts about, hey, can I do this? Is it even possible? And I don't have the expertise. One of the things that I like to tell them one of my own favorite personal analogies is, at least for myself, I live in California, I live in the Bay Area, and I have to drive. It's unlike New York, where maybe you can, to a large degree, maybe just rely on the public transportation or the subway. But for myself,
Yeah.
I have to drive. And I have to get from point A to point B, and getting from point A to point B to me is critical. Now, that means more often than not, I need a vehicle, I need a car. But you know what? I don't want to be a mechanic. Now, don't get me wrong. I'm not saying we don't need mechanics, but I need a vehicle just really primarily to get me from point A to point B. And as an embedded engineer, oftentimes you're saying, I don't want to be a data scientist. I can't be a data scientist, but I need a way to get from point A to point B so that the devices that I'm working with, they can now bring additional value to my customers. And so for me, the use cases that I really enjoy is not so much a technical one as so much as when I have an opportunity to sit down with a partner, sit down with an end customer at times and show them and illustrate how they can get from point A to point B, and to see that light bulb and to see that value transition from technology to gratification. Those are the use cases that I truly enjoy.
Awesome. My undergrad was in applied math, and I always tell people that I didn't like to just solve for X, right? I actually want the applications of math actually applying in the real world. And so those were the things that I always thought was really cool. Solving an equation, well, whoop-de-doo, but does that tell me how far I threw this football, for example? Well, now there's something there, right? Really good philosophy. And I think one of the things that I like to ask people that have been on the program kind of as we get near the end here is, people entering the field, how do you advise them, or how would you advise somebody that wants to get into this space? Like, are there classes, books, open source communities? I mean, obviously probably downloading Newton and just start playing around with it is something cool. But yeah, how would you advise somebody who wants to get into this AI ML space?
Yeah, there's a number of different on-ramps. I think Harvard, they partner with Google. They have an excellent program. There's so many on-ramps. It's amazing. But what I would say is maybe to some degree historically, and even still today, you still kind of run across this belief system that in order to do effectively, and we're talking about driving value, in order to do machine learning, you have to be an expert in math, or you have to be a hardcore coder that sits in a corner in the cubicle, late at night, pounding away on the keyboard. But for me, the reality is that I think the real area that I would encourage anyone to focus on is being a domain expert in the area of where you're looking to focus. Understanding the data is by and far the most essential step that you need to understand and take when you're building a model, irrespective of the tool that you're using. If you decide that, you want to go through, you want to build a model manually, and, you want to use R, you want to use Python, or whatever your tool of choice, the most critical and essential step is understanding the data in the domain that you're working in. If you struggle with this, then the possibility and the probability of you being successful, it really takes a significant nosedive. Earlier, we kind of joked around that, hey, junk in, junk out still rules the day, even after all of these various years. But even more importantly, understanding the features or the data points that you need as inputs to your model is absolutely critical. That's a part of our secret sauce. Whereas you may have existing frameworks that fully connect to every feature, and then you go through and with a scalpel and you disconnect different features that are not as important. That's the process, let's say, of pruning as an example, where our focus is we only connect to selected features that have the highest probability or highest predictive power. And a part of that is having that domain expertise to know which features are really going to contribute to what you're looking to predict on. So that's what I would really encourage people to start and really kind of focus their attention on.
Interesting. Yeah. I mean, at the end of the day, it's how are you going to change? How are you going to use the power of AI and machine learning, I guess, to actually change the way your business is run or bring value, I guess, to the market? And as you were talking, it feels like Newton would speed up that process. It would allow you to do something a lot more iteratively rather than if you were just to have to hire a bunch of data scientists, go through this whole rigmarole, then just to find out at the end of the day, well, we should have brought in this data instead, right? Can you guys, it feels like there's some value there. There's always, you're going to move faster the faster you can iterate.
Yeah, I mean, building a model is resource intensive. And you can say resource from a data perspective, from a resource, whether it's, let's say, you need to hire a number of different experts. And for sure, building a model is an extremely iterative process. Just to produce a model, let alone if whether or not it is bringing your organization value. So we definitely assist in accelerating that time to market. So if you are just kind of entering into this particular space, or if you've kind of reached the space where, hey, you kind of got it right now, you're looking to scale, right? So there's the right tool, obviously, for every situation. But in this particular case, yeah, absolutely. We definitely, it's one of our key tenets is, being able to accelerate your time to market, go through test out your hypotheses fairly quickly, and to really, really draw down or eliminate as much of, those headwinds when it comes to the number of resources that you would need, whether it's technically or whether it is from a human perspective or a resource perspective as well. So we really assist in both areas.
Yeah, for sure. In all these podcasts, I always have liner notes in there. So I will put all the information, of course, links to your websites and everything that we talked about. How do people best reach out to you, Blair?
My most active platform is LinkedIn. So I can always be found on LinkedIn. And I'm also not shy in sharing my email address. So first.last@newton.ai can also be reached as well. So
sure. Cool. Well, I like that you're giving back to the local school. I guess your core values with regards to what the company's trying to do, I think is very, very inspiring. Is there anything else that maybe I hadn't brought up that you wanted to highlight or talk about? Or you think we've talked about most of the areas that we wanted to today?
No, I think we've done an excellent job in the short period of time that we do have. And again, I want to extend my thanks for inviting me. I certainly appreciate it. Hopefully we'll do it again, or maybe we'll have an opportunity to do something together at an upcoming event.
Yeah, for sure, Blair. All right. Well, thanks again for your time. And yeah, definitely we'll be in touch and see you around in the AI community.
All right. Thank you.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.